Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's try this formula manipulation one. The time taken for one complete cycle of a pendulum is given by t is equal to 2 pi L over g, where L is the length of the pendulum and g is the acceleration due to gravity. Find L in terms of the other variables. Okay, so t is equal to 2 pi root L over g. Okay, so remember we always need L equals. That's what it means. Find L in terms of the other variables. And of course, it's perfectly okay to have your equation on the left equals L. Okay, right. So the way we do these is we find L in our equation. It's hiding here under the square root sign, and we see that it's surrounded by terms. So we strip away all of the other terms or all of the other letters from around it until we get L on its own. Okay, so the easiest ways to strip away from this one for a start would be the 2 pi. Okay, so if I divide that side by 2 pi, what I'll do is that will have the 2 pi and the 2 pi cancel. What I do to one side, I have to do to the other. So I have t over 2 pi now being equal to square root of L over g. Okay, the opposite of square root is square. Okay, square and square root are the opposite of each other. So to get rid of a square root sign like I have here, if I square it, what will end up happening is the square and the square root will cancel. What I do to one side, I have to do to the other. Okay, yeah, so that I get t over 2 pi all to be squared. Let me write that out. Is equal to L over G. Okay, now G is on the bottom here. So to cancel it, so it's there, I would say it's attached to L by division. So therefore, if I multiply by L, or sorry, multiply by G, because it's G I want to get rid of, you can see that one is on the top now, one is on the bottom, so it will cancel, okay? And of course, what I do to one side, I have to do to the other. So that I end up getting G times t over 2 pi all to be squared being equal to L, because that G and that G cancels, okay? Now, depending on how, I suppose your teacher wants your answer, they may want you to work out these brackets. Okay, this is a perfectly acceptable answer because we've now written L in terms of the other formulas. I suppose we haven't reduced this down to a simplest form, so it just depends on how the question might ask you to write it in a certain form, or your teacher might want a certain answer, okay? So again, I'm going to use this formula from the log tables, where when I have something squared, the top and the bottom, a fraction squared, the top is squared, and the bottom is squared, okay? So over here, that would mean, I'll just come up here and do it. I'd have G times t squared over 2 squared is 4 pi squared, okay? Being equal to L, or t squared G over 4 pi squared being equal to that L. So either of those answers is acceptable. So that's part one, find L in terms of the other variables. Okay, so it's a formula from physics, so it's not too surprising then when it's followed up with a scenario, and you have to work out the length of the pendulum that's going to cause this to swing. Okay, so given that t is equal to 3 and g is equal to 10 meters per second squared, calculate the length of the pendulum correct to 1 decimal place, the length of the pendulum. So L is equal to t squared g over 4 pi squared. Let's sub in the values they gave us. t squared is 3 squared, g is 10 meters per second squared, and then we have 4, and pi squared is just a number. So let me hit my fraction button. So 3 squared by 10 on the top, and on the bottom 4. I tend to use the pi button. Do you see it there sitting behind the by 10x down the very bottom of your calculator? Squared, because that ensures that there's no rounding error there. If I round it to 3.14 or I'll correct to 1 decimal place. Okay, and then the units, meters. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.